Okay, woo-hoo. Final two steps. Beyond these videos is building a website. Here's the goal. Turn over all the data gathered in the last 30 years. The micro mining is a small fraction of information collected. Over the years, non-workable information is weeded out, workable information is documented. You might imagine, in addition to refining data along the way, property locations were documented in the ore on that property. If you want this data, it'll depend on the donations from you along the way. So first, the videos on micromining will be released, and then the website, and then property locations which have had enough testing to be of value. The micromining release is my way of saying to the mining community, enough of being secretive, and let us get the show on the road. Let us dive in. One of the things that pushed this research towards a workable solution was admin. Your work has value. Write it down and make notes. This is your future. When documentation was added to my work, the path became much smoother. Somehow I will get to you what I call lab notes. In it, there is a tab, and it's an Excel program or an XLS file for leaching, fluxing, assay, and XRF. We'll put examples of each page in the video. What is not in the video are the formulas built into the spreadsheet page. The numbered ore, such as 356, are GPS locations which related to exact ore locations. GPS is crucial in the field. And yes, I'm over 350 locations. Some good, some not. Leaching is first in the spreadsheet we'll cover. It may well be reduction instead of leaching, but the salicylic treatment seems to do both. The iron turns to an oxide and the gold moves toward metal. Salicylic is full of carbon and hydrogen, both of which change precious metal oxides to metal. The sheet is self-explanatory, and here are the entries. Note the date of the leach is shown and carried into the next sheet, which is the flux sheet, which from there is carried into the assay sheet. Flux gives you the exact fluxes used, the flux sheet. The first three columns are simply the formulas for a 30 gram, 60 gram, and half pound flux. Half pound is 227 grams. In the left column, you will see the head ore as 454 grams or 1 pound. At the salicylic step, it was reduced to 421 and the APP was 424. That sample might not have been completely dry, I'm not sure, but it usually goes down. And you usually lose about 15% to 20%. In the first column, the ore weight is calculated by the weight of the ore. In other words, 93% of 60 grams is 56.04. In order for your assay to be correct on the 60 gram assay, we lost about 4 grams in the leaching, but the original 60 grams is now 56.04 grams. You also need a very accurate scale moving into thousandths of a gram. That's for weighing the seed. You must know the exact seed weight to calculate what was gained or lost. These numbers get carried into the assay sheet. What I use is pure metal from David Fell, the refiner in Los Angeles. You will see these numbers in the assay sheet as in quart or added metal. Then in the notes, you will see the starting time is when my smelt reaches 1750 degrees Fahrenheit. And noted when it is poured, and what temperature. Then under that is the zapping time and temperature before and after. For temperature, an X-Tech gun is used that focuses at 48 inches. Have had mine for at least 15 years. The model is 42570 and called Dual Laser 50, which is inches where the laser focuses. You will need one that goes to at least 2800 degrees Fahrenheit. There may be cheaper models out there, but this one works well. Also notice what is the collector and in what form. There is a huge difference between nickel oxide and nickel carbonate. If the flux was changed, it is noted in parentheses. In this case, 60 grams of nickel oxide was used per the flux sheet. Now underground, excuse me, understand if you use 60 grams of nickel oxide, you're only going to get as a metal probably about 75% of that, maybe as high as 80. Across the top of the sheet is which ore, in this case is 356, how much, 56.04 grams, then potassium carbonate, the sodium carbonate, then borax, calcium fluoride, silica, and sulfur, and all the fluxes used and quantity. Then your end product, the button, which is 39.5 in this case, weight, and the slag. We'll not go into what fluxes do. When the website is up, we'll post a book on fluxes and what they do in a smelt. Very short book, actually. For the more advanced students, here we're using sulfur as reducer instead of flour. Reducer in the smelt turns oxides and chlorides into metal. Before we move on, two things of note. Change only one thing at a time and assay. Two things create confusion as to what caused the change. The reason I mention this is on that sheet in very small print is a note, 50/50 oxide and metallic nickel. Ground metallic nickel is less expensive than nickel oxide, so I tried it, and it reflects on the assay sheet. Less values in gold and silver. Next is the assay sheet. Ask for your XRF results to be reported in percent. This is most common with XRF. Starting at the top, the date reflects when the leach was done, then when the smelt was done, and the last one is the XRF results. Next is the XRF results, which will be in percentages. In this case, the button was shot top and bottom, and those two results were averaged to get a percent of metal. By doing this, it was later found that shooting the button on the side gives an average and eliminates two shots from the XRF, which costs me 25 bucks a piece. Again, the name of the ore, the weight of the button, how much ore is represented, in this case 60 grams, then the metals we are interested in. Toward the end of the XRF values, the largest known element besides the collector, and then the collector. If one had a large amount of lead or cadmium, like 5%, move on to another ore. The refiners do not like those two elements. Going down the page, which elements were used as in-quart besides the nickel? It is noted there, gold, silver, and palladium. Next is where the palladium in-quarts are transferred to the page from the flux sheets. So in this case, we put in 2.096 grams of palladium, and the button has 3.107 grams, or a 1 gram gain. Most of you know this, but when converting percent to a decimal, one moves the decimal place 2 places to the left. 4.295% is, as a decimal, 0.04295. Then when you look at the in-quart versus what is present in the button, one can calculate the gain or loss. This is your assay. Let's look at the gold. In-quart was 2.003, and the button was, what was in the button was 0.774. So 1.229 grams of gold went into the slag or not recovered. In this case, that was metallic gold, actually, that we put there. What did we learn? Do not use metallic nickel for a collector. From my experience, the palladium, gold, and silver will be close to one another in value, but not always. Going back to the head ore assay, the palladium is listed as, now this is the powder that we shot in a little cup. The palladium is listed as 571 ounces per ton, and we recovered 492 ounces per ton. So, I'm just going to travel off the script here a little bit. So this basically shows you that those values that XRF is shooting in powder that nobody else can recover are there, because now we've recovered close to what the head ore assay in the powder was. Then when one reviews the assay on the powder samples from the 2 leaching steps, these are the values we are shooting for, and another run at this using just nickel oxide should increase the value substantially. So this is a good ore after that second assay will be done. These numbers on the powdered leach, APS in particular, is what tells me if this is a good ore. This is how the process came about. The XRF was never doubted, and we kept researching. If one can get even close to half an ounce of gold and palladium, that's nano to metal, per pound, this is a good ore, and it's cost effective. For some reason, there is still too much iron present for the AU to show up in the powdered samples from the XRF. So don't panic on that one. But will show up in the button, and that's where it's metal. By the end of the presentation, you will also learn about by the end of the presentation, you also learn that about 500 ounces per ton from both the palladium and gold is necessary for the process to be cost effective. Most common ores will produce this, and there are better ores as well. So that you begin to think with this, there is 2,000 pounds in a ton and 908,000 grams in a ton. So 500 ounces per ton is then 1/4 of an ounce per pound, which are nano elements converted. Some time was taken to go over the lab notes so you know the answers to most of the questions is to assay and find out. Should be mentioned that over time and documented research, this is what was found about the XRF. The Niton handheld machine has logarithms installed to denote rock and powder from metal. So the trick was to bypass this. The logarithms were put in place as no one could recover what the raw ore shot. So when using Niton, always shoot in precious metals mode when shooting powder. The tabletop fisher does not have such features that I'm aware of. Have tested the Bruker handhelds and one from Israel called an Elva. These are all good machines, and anyway, so on we go. Have pages of research on XRFs as it is on my Christmas list. To research this properly, one takes 3 known buttons that have been shot, or you know what is in it by putting seed in it, and send it to one manufacturer. The buttons are returned and sent to another, etc. Then all the data is collected and compiled and compared. Any research I have may be outdated somewhat, but you can have it if you shoot me $25 and I will email it to you until the website is up. The criteria was used, the criteria that was used is, do these people respond when you need help? And the results of the XRF shots speak for themselves. Back to the assay sheet. By calculating the recovery, you see there are minus results. That means those values went into the slag. When that happens, the slag is crushed, panned, and the cons or concentrates are refired. Trust me, over the years, have had some bad smelts. I also cheat by fluxing and use a small induction furnace to get back to metal. In an induction furnace, I can fire a smelt in 10 or 15 minutes as opposed to 45. Let us move on to smelting. A large gas fired furnace is used where one can reach 2400 degrees Fahrenheit. Most of my smelts I pour at 2100 degrees Fahrenheit minimum. A and B prospecting supplies in Phoenix is where I buy my furnaces, or you can build one when the website is up. I've got pictures of how I did that. And you'll see it in the video. I'll put it up towards the end. Crucibles I buy from Legend Mining Supplies. You want clay crucibles, not carbon, as any form of carbon will suck up the values in the bottom of the crucible, and that includes graphite if you're not aware of that. The rule of thumb is your fluxed ore fills half the crucible, or maybe 60% of the crucible. This allows for the reaction during the smelt, and your values do not end up in the bottom of the furnace. You will want to find some bone ash to coat the floor of the furnace with, which is easier then to clean up when you do have one that overflows. About half an inch will do. 6.5 inches and 5 tall and 5 inches wide, or what, I'll give you that again. 6.5 inches tall and 5 inches wide, or what Legend calls AP green, number 6, for the 60-gram assays. And you can use those crucibles, reuse them 3 or 4 times, 5 times. You just pay attention to that notch and see how close, how much is being eaten out of your crucible each time. For half-pound pours, 8.5 inches tall and 7.5 inches wide are what AP Legend calls AP green number 12. And I have cheated on some of those smelts, and I pour in, go 60%, fill it up, heat it up, let it react. When it drops down, then I add another portion of the other half pound until I get it all in there. If your smelts are cutting large grooves into the side of the crucible, add silica to the inside of the crucible. You can find some of your fluxes at Home Depot. pH up in the pool supplies is sodium carbonate. I've also found potassium chloride in big bags, but it's not finely crushed in the water softener area. Most fluxes you can find online. The larger the quantity, the cheaper the product. I find nickel oxide at the ceramic suppliers. Okay, you got your fluxes in your furnace. I found an inexpensive welder from China for about $400. It's cheaper if you buy one that uses maybe 10 to 15 amps at 220. I made a cord that plugs into two 110 sockets and then a 15 amp 220 receptacle. So these two 110 cords go into a one box and then a 15 amp 220 receptacle. Let's see. Just have to make the cord long enough to reach 2 different plugs. Has to be 110 on either side of the breaker box. So your breaker box in the US runs 110 down each side, and then you've got your breakers. So if you plug the 2 plugs into this side, turn your welder on, nothing happens. You know, you keep moving around until you find a plug. One plug is on this side of the box and one plug is on this side of the box in the room. All right, the jacket and gloves are from a local welding supply, nothing special. Use a welding hood for zapping. Working on a different approach that may eliminate the zapping, but a bit more dangerous. First a fusion, then a smelt. You will know about this when the documentation has occurred and it is successful. These little gas-fired furnaces can be tricky to light. I use a squeeze bottle filled with alcohol and some small wooden blocks. Put the little wood block in the edge of the furnace next to the crucible block. So the crucible sits on a pad, a small pad. You don't want it on the bottom of the furnace. It needs to be about a half an inch up. So then you drop that little block in there without the crucible. You spray the side of the furnace down to the block and soak it. Put the crucible in and light it at the top, and it follows the flame down, and then you can start with your propane. So put the little wood block in the edge of the furnace next to the crucible block, wet the wood block and wet the side of the furnace with alcohol, add the crucible quickly and light the top of the wet surface near the top of the furnace like a wick. Then turn on the propane slowly. The wood block ignites when the propane burns and keeps the furnace lit at low temperatures. I come up slowly, especially with a cold crucible. I cover the top of the smelt with salt, either potassium chloride or sodium chloride. This melts at about 1600 degrees Fahrenheit and keeps the unmelted fluxes in place for about 20 grams of salt per 60 gram assay. Then while the furnace is coming up to heat, the welder is set up close enough to the furnace to zap. It may take about 20 minutes to get to 1750 Fahrenheit. And I start kind of low on the propane, and then at 900 degrees, then I crank it up and create more heat. Once the salt begins to get wet, you are close. At 1750, by using the laser gun, the time is recorded. This is what they look like. At about 25 minutes, your smelt will begin to smoke more than usual, and all the reaction is down in the crucible. Looks like orange water. There won't be any bubbling, any foam, or nothing in that crucible. Then it is time to zap. The furnace is turned off, and now the two electrodes are placed slowly into the smelt. You do not want the positive on the bottom of the crucible, and you do not want the two electrodes touching one another. The positive stays just into the liquid, and then drop the negative into the liquid. A reaction will begin in the liquid, and metal will form and drop at the cathode or the negative. On the welder, the picture of the clamp is the negative. When you look on the welder, it's got a little picture of a clamp. That's negative. I use 3/8 inch copper coated carbon rods, which are purchased from a welding supply. Two of the rods are clamped together, shown in the picture, stainless only, so that extends the rods. When the rods burn up or gets too small in the ends, remove the clamps, sand the top rod, and add a new rod on the bottom. It does not hurt to get the negative into the metal in the bottom of the crucible, but don't leave it there long. If you drop the positive, it'll draw metal from your potential button back into the slag. This takes a little practice. If you're not happy with the zap, turn the furnace back on, get the temperature back up. Usually the zap takes place at 2000 degrees Fahrenheit or higher. After the zap, one should observe the smoking has decreased from the furnace. When a heavy cast iron pouring mold is used, it is gently placed on top of the furnace to heat. If there is any moisture in or on that mold when you pour, there will be an explosion of the slag. About 300 to 400 degrees Fahrenheit is fine. Then remove it for the pour. The pour should be about 10 minutes after the zap. All of this is noted on my flux sheets, and your pour should be about 2100 degrees Fahrenheit or higher. If your furnace runs up to 2400, this is a better temperature for nickel. Do not bump the table where the mold is located right after pouring the nickel, or your button won't be a button. It'll do something funny. The mold and the slag button is allowed to cool. The slag should pour like water. If it is thick, one needs to add silica, and calcium fluoride thins the smelt. Sulfur also thins the smelt, but more caution is needed in adding sulfur. Too much sulfur causes something we call speece on top of the button, and it's not a button. Anyway, you don't want that. Once the slag reaches about 350 degrees, one can pick up the mold, turn it upside down on an aluminum tray. Always wear eye protection around hot slag. As it cools, it will be cracking and blowing small chips around. The welding gloves work for all the work done so far. For your next step, I use a chipping hammer from a welding supply. The cooler the slag, the easier it breaks apart. Don't forget to coat the mold with some form of carbon. We use an acetylene torch without oxygen. Light it, run it around the mold until it's black with soot. I have heard of people sprinkling flour on a mold, never tried it. If the slag does not fall out, either it is not cool enough or there is a lack of carbon on the mold. Then a light couple of taps on the upside down mold usually drops out the contents. Don't get crazy chipping the slag from your button. It is nickel and it is brittle. We tap off most of the slag and then use a small ultrasonic for about 20 minutes in hot water to clean the rest of the button. It is now ready for XRF. Weigh it, put it in a plastic cup with a lid, label it, and now your samples are ready to ship out. Shown here is a sheet I use when the samples are sent out. The name of the sample, the weight, and the cost is what is on that sheet. A package is sent inside of a package with a return package with postage. The technician opens it, shoots the sample, puts it back in a return box, and ships it. The person I use charges $25 per shot, takes a picture of the sample and the XRF screen and emails me the results. The weight is written on each small plastic cup so that when the buttons are out, they cannot be confused. If there is a confusion, one weighs the button and puts it back in the correct container. When you email him, he will give you his PayPal account for payment. Payment is in advance. And it'll be on the screen there. I put it large, the email address and his name. Your button, if the ore is good and not a sulfide ore and not black sands, will look like some that are shown. Black sands take a completely different flux, and the leaching solution would have to be at least double the phosphoric acid. There's often chrome in black sands, and phosphoric is what you use to knock the chrome down. I've never messed with it much, but I know that much. Where do I sell the metal? Due to the process to remove the nickel, it is sold at this point. That process to break the precious metals from the nickel is more work than what we've covered so far. What can you expect? If the values are over 20% in your buttons, they will pay spot for the precious metals, less 10%. If your metal is under 20%, if your precious metals are under 20%, they will pay you spot less 20%. There's a good refiner in Belgium and they know how to process nickel sulfide. I will get in touch with them and pass that along at some point. Most of the scrap refiners don't like nickel. Have found a couple in LA which will take nickel. They are not into one button or two. They generally want pounds. They like copper, but copper eliminates the palladium. If one found a high-grade gold ore, one could use copper, don't seed for palladium, and substitute in the flux, take out the sulfur, and add flour. I know of a refiner will pay spot less 10% for gold and silver and copper. That's easy to sell all day long. Pouring a hot liquid takes practice. One aims for the center of the mold and starts slow and dumps quickly. They have a dark face shield that's welding supplies they use when you're using a cutting torch, and you will have to find the proper tongs for your two crucibles. Some basics are never pour acids or hot liquids at eye level. We'll include an old video of 1 pound pour from a furnace made from a stainless pool filter just for fun. It was my first furnace and it was at least 15 years back. We'll include an old video, one word of advice. Don't abandon a known income for something that has not been fully tested and replaces the old income, or better yet, add the new income to the old. If you find this video helpful, we'll add PayPal account to the notes. If you want to email me until the website is up, a copy of the lab notes, let me give that to you again. If you want me to email you a copy of the lab notes where you can just plug in numbers and it does the rest, send $25 and email me. And then my email address on the screen. The website will be BillEarnshaw.com when it is up. Thanks.